helpful for when we don't remember the multiplication. So I'm just going to clear my calculator so that whatever was done on it yesterday doesn't mess it up. So I'm going to hit the second button, the blue button. So second, and then I'm going to hit a plus sign. So second plus, so it looks like this. And then I'm going to hit the numbers 712. 712. So second plus 712, and I just cleared the memory. There we go. Okay. So, and then your calculator should look like that, and it's back to just being all cleared now. Okay. So let's do r squared minus 12r plus 35. And so what we're looking for is two numbers that multiply to a positive 35 but add to a negative 12. Multiply to a positive 35 but add to a negative 12. So I'm going to take my calculator, and if I want my calculator to help me with the multiplication, what do I type? What screen do I have to go to? I have to go to the y equals screen, so it's kind of like I'm graphing something. I go to the y equals screen, and what do I type there? I want to see what multiplies to 35, so I'm going to do 35 divided by x. Yep, and you always divide it by x. So 35 divided by x, and then if I wanted to see what the graph looked like, I would hit graph, but I don't care about the graph. I just want to see what the table is. I want to see what the numbers are that multiply to 35. So I'm going to hit the blue button because I want the table, and that's in blue. I'm going to hit second graph, and these are all of my options, and I ignore the ones that have decimals in them. So 0 times error, 0 times nothing is 35. That's why it says error. So 1 times 35 multiplies to 35, but that adds to 36. So that's not right. The next one's a decimal, so I'm going to ignore it. Decimal, so I'm going to ignore it. Decimal, so I'm going to ignore it. 5 and 7, those multiply to 35, and they add to positive 12. So that gives us kind of a hint. So I'm ignoring the decimal, 7 and 5, 12. Ignoring all these decimals. So this seems like it was probably the wrong direction to go. So what should we do instead? Go the negative, go the other way. Because we know a positive times a positive could equal positive 35, or a negative times a negative. Yeah, could equal positive 35. So negative 1 and negative 35, but that's negative 36, so that's not it. Ignore the decimals, and then negative 5 and negative 7 multiplies to a positive 35 but adds to a negative 12. So the two numbers would be negative 5 and negative 7, and so in the parentheses we just write r minus 5, r minus 7, and if you put r minus 7, r minus 5, you're still right. You can put these in backwards order and you're still good. Okay. All right, how about x squared minus x minus 90? So what are we looking for here? Multiply to negative 90, add to, not 0, because if it was 0, it wouldn't be there at all, right? So add to 1, positive 1 or negative 1? Negative 1. Okay, so we're going to go back here. We're going to hit our y equals button, and we're going to say negative 90 divided by x. So we're looking for two numbers that multiply to negative 90, but add to negative 1. So if we're multiplying to a negative number, then we're going to have one number that's positive, one number that's negative. And now I can hit second graph to look at my options. So this adds to 89. This adds to 43. These add to 27. This is a decimal, so I'm ignoring it. This adds to 13. That adds to 9. Ignoring the decimals. That adds to positive 1. So what's the answer? So 10 and negative 9 would be positive 1. 9 and negative 10, yeah. So x plus 9, x minus 10. Okay, k squared plus 22k plus 120. So we're looking for two numbers that multiply to 120, but add to 22. So what do I type in my calculator? Okay, and then I do second graph, right? Oop, I don't want to actually see the graph. So second graph, and we're adding to a positive this time, so I don't really want to be on the negative side of things. So I'm going to go over to the other side. And you can kind of tell when you're on the right track. So right here, these multiply to 120, but they add to 121. That's a really big sum. These multiply to 120, but they add to 62. So the sum is getting a little bit smaller, so we're going in the right direction. Multiply to 120, but they add to 43. Multiply to 120, but they add to 34. So the sums are getting smaller, which means they're getting closer to 22. So we're headed in the right direction. We're just not there yet. So down here, we're at a sum of 26, so we're even closer now. So what are the two numbers? Anybody? What are the two numbers? 10 and 12. So we have k plus 10 and k plus 12. Okay. Do you guys feel ready to practice your own? Yeah? Okay. So we're doing a punchline worksheet. Let me go ahead and hand out the punchline to you, and then I'll show you guys how it works. I think I can hole punch this. Let me go ahead and do that real quick. Okay, so let's find a number that looks intimidating. I'm I'm going to, I will work off, I will do 10, 11, and 12, 22, 23, 24, and I'll tell you what the answers are once I do them, because I don't feel like we need to know how to do these problems as much. They're not very common. So you guys won't be doing those. You guys will just be doing these 3 columns. So I'll tell you the column on the very right, and I'll give you the answers for those so you guys can still do the punchline. But of the first 3 columns, which problem should we do? Number 5? Okay, let's do number 5. So for number 5, we are looking for 2 numbers that multiply to negative 30 and add to what? Add to negative 1. Yeah, it's not 0, right? Because if it was 0, they wouldn't even write it. So we're looking for 2 numbers that multiply to negative 30 but add to negative 1. Okay. So I'm going to do, if I want to get rid of this, I can just hit the clear button right there underneath the down arrow. So I've got negative 30 divided by x. And then I can hit second graph. And so which of these options adds to negative 1? So every single pair multiplies to negative 30, so that part is already taken care of. We just have to find the one that actually adds to negative 1. Anybody see it? Negative 6 and 5? So this would be w minus 6 on w plus 5. Okay, and so what it says is write the expression in factored form, so we did that. Find your answer below and cross out the letter pair next to it. For each letter pair that you do not cross out, you're going to write the uppercase letter in the box containing the lowercase letter. So w minus 6 and w plus 5, w minus 6, w plus 5. So this answer we're going to cross out. We're getting rid of this answer. So when you are done with this, you're going to have 3 answers crossed out and 2 answers left over, right? Because there's 3 problems in here, so you're crossing out 3 answers and you're going to have 2 left over. And then what you're going to do is you're going to look down in these lowercase letters and you're going to have an uppercase letter that corresponds with it, and that's what you're going to write in the box. And when you're done, you're going to have a punchline that answers the question, what happened to the guy who lost the pie eating contest? Okay? So if your answers were right for the whole thing, then your punchline will make sense. If your answers are wrong, then your punchline will be gibberish. So that's why we do the punchline, because it helps us check our answers and make sure we did the problems correctly. Does everyone understand the instructions? So as you get the answers, you scribble them out, and the letters that are left over go down into the punchline. The leftover letters. So the answers get scribbled out, the leftover letters go down into the punchline. Okay? Make sense? We are only doing the front side for now. Once we practice the difference of squares more, then we're going to go ahead and do some more practice for that. But for now, we're only doing the front side. Okay? So go ahead and get started on that. I'm going to do 10, 11, 12, 22, 23, 24 for you guys, and I'll tell you what the answers are for those in a minute. Okay? I'm just going to do those real quick. Okay. So here's the next one we're going to do. It's similar to the ones that we just did, but there's one thing that's a little bit wrong with it. So we're adding this to our notes. What is a little bit wrong with it? There's only two terms. We're missing the middle term. What does the middle term usually have? An x. And if it's completely missing, what number would have been in front of it? A 0. So I'm going to take this, I'm going to rewrite it. I'm going to call it x squared plus 0x minus 25. And then if I do this one the way that I've been doing the other ones, I'm going to say what multiplies to negative 25 but adds to 0. What multiplies to negative 25 but adds to 0. And does anybody know what it is? Multiplies to negative 25 but adds to 0. What is it? 5 and negative 5? Okay. So the answer is x plus 5, x minus 5. Oops. Let's try another one. For this one, let's do, what did I do yesterday? Okay. For this one, let's do x squared minus 9. So again, it's missing that middle term. So what do? Put a 0 in there. Okay. So I'm going to rewrite this, and I'm going to say x squared plus 0x minus 9. And then when I do the problem, I'm going to say, okay, what are two numbers that multiply to negative 9 but add to 0? Make negative 3 and positive 3. Okay. So x minus 3, x plus 3. So we did some of these in the video, and then we've done a couple of them here. So x squared minus 25 is x plus 5x minus 5. X squared minus 9 is x minus 3 and x plus 3. Christian, you listening? Yeah? X squared minus 36 is x minus 6x plus 6. Jordan, you listening? X squared minus 81 is x minus 9x plus 9. X squared minus 16 is x minus 4x plus 4. Is anyone seeing a pattern with any of these? What's the pattern? One's negative and one's positive, so you have two signs. What's another pattern? They're the same number. So it's a 4 and a 4 from the 16. It's a 9 and a 9 from the 81. It's a 6 and a 6 from the 36. It's a 5 and a 5 from the 25. It's a 3 and a 3 from the 9. What's another part of the pattern? Is there anything else you're noticing? There's something about multiplying, right? Like, okay, so let's say I don't want to show all my work and I want to do x squared minus 64. Does anyone know what the parentheses would be without showing their work? We said we know the numbers would be the same, and we know that there would be a plus and a minus. What would the two numbers be? It'd be 8. How did you know it would be 8? Yeah, 8 times 8 is 64. So what types of numbers are these? 64, 9, 25, 16, 81, 36. They have a special name. They're not even, because 81's odd, but they have a special name. Anyone know what that special name is? They're called perfect squares. It's something squared, 4 squared, 5 squared, 6 squared, 7 squared. So if I were to take this one, x squared minus 64, then Dylan, you were right. It'd just be, we would be using 8 for each of them. X plus 8, x minus 8. So those are the two that we have. All right. So let's go ahead and practice some of these first, and then I'll show you guys how to do some of the more difficult ones that are like that. So I'm going to hand out a sheet to practice some of these. So we're going to take these difference of squares problems, and we're going to make them a little bit more complicated, okay? Not terribly. Not terribly. We're going to make them a smidge more complicated, okay? So this is still underneath the difference of squares heading, okay? We are taking them and we are adding a slight step to them, okay? So I'm going to do just another difference of squares problem, because they can be this simple. Oftentimes they are that simple, but sometimes they do a little bit more. So you're still going to be looking for those difference of squares numbers. And so on our difference of squares notes, let's write down all those perfect squares so that we don't forget them. So I'm going to write off to the side 1 squared equals 1, 2 squared equals 4. I want these perfect squares in my notes so that when I see them, I recognize them. 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. How high did it go on your guys' papers? Anyone remember? 13, okay, so 11 squared is 121, 12 squared is 144, 13 squared is 169. We'll go ahead and leave it at that because that seems to be like the recognizable ones. So anytime you guys see a problem and it has 2 terms, so 2 terms, not 3, just 2, and it's got a minus in the middle and it has these types of numbers in it, then think about these types of problems. These are the easier ones. 1 plus sign, 1 minus sign. And you think about basically taking the square root of the number, right? The square root of 81 is 9. The square root of 16 is 4. The square root of 36 is 6. That's kind of how you get to each of the numbers. Now, for these types of problems, when they make them a little bit more complicated, you might see something like 25x squared minus 9. So this time, they didn't just say x squared minus 9. They actually put a number with the x also. Okay, everyone see that? 25x squared minus 9. So now there's 2. So the problem works out really, really similarly. It's just slightly different. So we're still going to have 2 sets of parentheses. We're still going to have a plus on one. We're still going to have a minus on the other one. We're still going to say, okay, this is a 9. And 3 times 3 is 9. And so I'm still going to say I have a 3 in the first one. I have a 3 in the second one. We're still going to do that just like we did before. I'm still going to say that x multiplied by x is x squared. So I'm still going to say, okay, I have an x in the first one, I have an x in the second one. You can see that I'm leaving some space. Because now I'm going to say, oh, I have a 25. And to get 25, they must have done 5 multiplied by 5. And so I'm going to put a 5 in the first parenthesis and a 5 in the second parenthesis. So I still have 2 sets of parentheses that are almost identical. They just have opposite signs. 5x plus 3, 5x minus 3. So it changes the problem slightly, but not very much. Everyone see that? Okay. Let's try another one. Okay, let's do 144x squared minus 49y squared. So we're going to have two sets of parentheses, one with a plus, one with a minus. And the first spot has a 144x squared. So if we square root that, if we say what multiplied by itself gave us 144x squared, what was it? 12. And then what else to get the variable? X, yeah. So 12x multiplied by 12x, that has to be how they got 12x squared. So we're going to take the first spot and we're going to write 12x and 12x. Okay? And then for the second spot, we have a 49y squared. How would they have gotten a 49y squared? They multiplied 7s, and then how did they get the y squared? 7y. They must have done 7y multiplied by 7y. So we're going to put a 7y here and a 7y there. So 12x plus 7y, 12x minus 7y. Okay? I'm going to fit one more problem in here. Let's do 81x squared minus 4y squared. Okay? I want you guys to try this one on your paper. So take a moment, try this one on your paper. Let's see if we can get this one right. So 81x squared minus 4y squared. You're going to see if you can get just this one problem. So two sets of parentheses, one with a plus, one with a minus. Think we got it? Anyone want to say what they put in the first spot? Yeah. 9x. Okay. 9x plus 2y. And then what about the second one? 9x minus 2y. Okay. Now, these ones are usually so simple that students forget them and get them wrong. So that's going to be the tricky part, is us remembering how to do these tomorrow and then remembering how to do these the day after, because they're so simple we might forget them. Okay, take the worksheet you had before and flip it over. We are going to put dots or stars or whatever next to the problems I'm going to make you do on this worksheet. This is the back side. It's not very many. Might just do, I might leave it at that. Yeah. Okay, I'll go ahead and leave it at that. So on the back side, you're only doing the first 6 problems, okay? So no punchline for the back side. We're just going to leave it there. But the whole front side you have to have done, okay? We have a video tonight. Do not pack up, because we got a solid 7 minutes of class left. So work on those problems on the back. You might be able to finish those before class is over. We do have another factoring video tonight on notebook paper again, because this is not the only type of factoring. So for classwork, remember we had the front side of this worksheet. We have 6 problems on the back, and we had the half sheet. And so that's what I'm collecting tomorrow, is the half sheet and then this sheet. And then for homework, we have a factoring video. because we're doing some more factoring review tomorrow. Sound good? Marvelous.